Okay, this video is basically a continuation or a part 2 of the one I uploaded a little while ago called Flat Earth Objects Disappear at the Horizon. Still using the same program, Blender, and actually basically the same two files and two situations here, one with the sphere or the globe and then one with the flat plane. The main difference is that I've added an object that is going to be made of glass in Blender, which is you can change. If you take any object, you could change what material it's made of, and one of the ones you can choose is glass. And glass objects in Blender actually work very closely to the way glass works in the real world. You could change its index of refraction. So here I have it at 1.25, which isn't exactly what glass is, but it's fairly close, and it will demonstrate the concepts I present in the video. And right now you're looking through the camera, which is positioned here, so that the glass is between the object and the camera. And right now you can't see through it because I'm in what's called material mode, but when I switch to render mode, you'll actually see the object appear as glass, mostly see-through, because of the difference, the taper here on the glass object, thicker at the top and thinner at the bottom. It'll actually act like the atmosphere being, well, in this case, this is going to basically show, I'm going to be showing two different atmospheric phenomenon. One's called looming and one's called sinking. And this will actually show sinking, which makes the object appear to be lower than it actually is, where looming, which is just the opposite, will make the object appear to be higher, so it seems to be floating above the surface. But I'm going to be doing looming here first. So basically, if you look at the glass here, I'll get rid of, you can see that it's thinner at the top, at the bottom, right at the surface, and it gradually gets thicker. So basically that simulates how the air can be thinner at the bottom and thicker at the top if, say, you had a warmer air with cooler air below it, which doesn't happen a lot. It's usually the opposite way, where objects are more looming than sinking and they're higher. But I just wanted to start off with this, and then I'll just basically spin this glass around, and then it'll be thicker on the bottom and thinner on top, and I'll do the opposite effect. But first, again, this camera is facing towards the cube, so over here I'm able to make objects visible or not visible to the program. So right here is just a straight up view from the camera to the cube, and you can see pretty much the entire cube at this distance. But then if I then turn on or make the glass visible and then go into rendered mode, it will actually render it as you're looking through the glass. And it's a little bit subtle here, but you can actually see that now it appears lower, and I'll toggle the glass on and off so you can see the effect. So there it looks like it's a little bit higher, and when I turn it on, it actually drops it lower. And this could be seen to be a little more dramatic at a distance. So I'll basically going to turn off the rendered version for just a second here, because actually the computer has to work a lot harder when it's in that mode. So then here I'll back it off. The camera now will be moving backwards, further away, just like in my previous video. And I'll move it to the point when you can just barely see the red. So right here you can just barely see the red, the bottom third or so of the cube. Now that's with the glass not there. If I enable the glass and enable the rendered view, you'll see that it's now dropped it. So it appears lower, so you could just barely see and probably can't even see the red. But then if I turn off the glass, then you can see the strip of red appears again. So basically with the refraction from the glass in between the camera and the cube, it's bending the light rays down so that actually it bends the light rays up so that the object at the distance appears to be down. And I'll explain how that works in a second. So go back to material. And I'll move the camera closer a little bit. Okay, so here's the camera again. So basically what's happening when it goes through this, if the glass, or again, if the atmosphere was the same density from the bottom to the top, it would act like the glass is the same, which means it acts like it's not even there. So I'll turn off the glass to begin with here. And the reason you're just not seeing any distortion is because if it was all the same density, there wouldn't be really any distortion, it wouldn't be bent. So the light rays would be going straight from the object, bouncing off the object, and going into the camera or your eye. So show here, so if you're seeing a part of this red right here, the line is straight and goes right into the camera lens or into your eye. But when you add in the refraction, light goes, and when it encounters something, substance, air, or glass of a different density, the light then bends. So it comes in at this angle, but then as it refracts through the glass or through the denser, or actually less dense air, denser air, it will be bent up. So that same light ray that would have went straight to the camera actually goes above it. But then also, since rays are scattered in all directions when they hit this object, that's how you're able to see it from different angles. And above it you can see the cube, and below it and straight on you can always see that part of the cube. So for a light ray to get into your eye, it just has to be at a more of an angle. So if it comes down here, for another ray coming from the same spot, it's bounced and comes down here. Again, it's refracted and comes up at an angle and goes into the camera lens. But get here, different color. So now that the light, but since it's bent, it will appear to be lower in this instance, and I'll show you why. Because if you extend this line, so if it's straight on, you're seeing it at its correct height. But if the light is bent, you're actually seeing it as if the light that's getting to your eye, once it goes through what's refracting it, it continues on a straight line. Well, basically straight there. So this point here, once it's refracted and goes up here, actually appears to be this much lower. So even though you're seeing this point, because it's refracted, it'll appear to be this lower to your line of sight. And if you move further back, with the camera, and further back, see that those light rays go there. And they're bent up. But the ones towards the bottom are, now if they even get there, they're bounced up. But if they're any lower, they get blocked by the curvature of the Earth, or the sphere in this case, and they won't actually reach. So you have to be at a certain height above the horizon to be viewed by the camera or your eye. So that's how, when you get far enough away, you won't be able to see the bottom if it's a clear day, or if there's a lot of refraction going on from the atmosphere. And either it'll appear lower, again I'll show that again. So we'll back it up here. Till the red is just a tiny little sliver there. And if I turn on the glass there and put it into rendered mode, see the effect of it, and you can see it actually drops it down below. And if I turn it off, you can see, now you can see the red. If I turn it back on again, you won't see the red. And that's for sinking. And the other atmospheric phenomenon is called looming. So if I zoom in here, get the camera kind of back closer, and zoom in, I can actually rotate this around so that the thicker part is at the bottom. So we'll do that here. So I'll rotate it around its center point, and get it so that the thick part is on the bottom. So now you have it just the opposite, and this will actually cause the object to appear higher than it actually is, because you have the denser air on the bottom, and then it gets less dense. So this is denser, or there's more glass in the way here than up top. So it's going to reflect the light and bend it, so it's bent down, which will then make the object appear higher. So I'll demonstrate that here. So go on, we'll turn the glass back on. Well, the glass is on, and then we're going to turn into rendered mode. And here you can see that the object appears higher. And if I turn off the glass, it sinks back down. And if I turn it on, it goes up again. This to be shown from more of a distance. So you get to a point when the red just goes below. So now you're just seeing blue. If I turn on the glass and put it into rendered mode, you could see the little bit of the red, because it's, again, the object is being raised up. And if I turn it off, then it sinks back down again, turn it on, and it comes back up again. You can see the red. It's very subtle here, because I want to keep the amount of refraction fairly consistent with what would actually happen in the real world. But that basically shows that, again, this is looming versus the sinking before, and this is on a sphere. So again, you could see that if I turn that back on there, off there, and move the camera a little bit closer here, zoom in on it. Here's the camera here, and kind of the same thing happens, just in the opposite direction. So instead of bending the light up, it's going to be bent down. So if you have right here, right at the very top of the red, when it's coming through, a certain ray hits the glass, it's going to be bent down. So when it comes out, it's actually going to be lower than normally would. But a light ray that was refracted at more of an angle, when it is bent down, it actually go into the lens of the camera, so you can see it. But again, because of this angle, what you apparently see would look like that point is actually up higher like this. So even though it's actually here, because of the refraction, it raises it up and makes it look like it'd be at this height above the ground. But as the distance between the viewer and the object gets greater, eventually the curvature here is going to cut it off, and you're not going to be able to see the object, and that's going to go curve from bottom up. First stop being able to see the bottom, and then goes all the way up to the top, and that was explained in the other video. This is just adding in the effect of the atmosphere and refraction. Now, yes, this glass is not air, but it is using the same phenomenon and the refraction both down and up of the light rays to show the two different main phenomenon of looming, which raises looks like the object higher than it normally is, and sinking, which makes it look lower. And you can also have mirages and other atmospheric aberrations and distortions, but this is the main thing that makes it go up and down. This is what makes the object appear higher or lower. And then now I'll just quickly open the one when it's on a plane. And again, this is the same thing, but now it's on a plane. And you see the object, the glass is the same, it's still glass, and it's tapered, smaller on the bottom and more on the top. And when I change it into rendered mode, you'll see that again, the object now appears lower, but you can still see the red, you can still see the blue. If I turn it off, there it is. Turn it back on again, you can see that it's lower. But as I go away, going further and further away, you're still seeing the same amount of red and blue. And when I zoom in, again, you can still see the same amount of red and blue. And if I turn the lens off, or the glass off, again, you can see the red and blue. It just appears lower, but you can still see it even at a distance or close up. It just drops its apparent position for the same reason as I just showed before with the light rays bending. So there it is up its normal position, and there it is refracted, so it looks like it's down. And I'll do the same thing I did before. I'll select the object, and I'll rotate along its center until the thicker part's on the bottom and the thinner part's on the top. And I'll change it into rendered mode, and you can see that it raises it up, and as I move back, still raised up. And then you can zoom in and you still see the same amount. And at no point here are you seeing any of it obscured, because on a flat plane there is nothing to block the light from going from the object, even if it's refracted, since the light's going off in all directions. You're still going to be able to see the entire object from a distance until it just eventually, from perspective and just the capabilities of your eye or the camera, eventually you won't be able to see it anymore. But it's not going to go away bottom first like it will on a sphere, because again, on a flat plane nothing's blocking it, and you can have it blocked by atmosphere, but that's like what fog, or if it gets blocked, the whole thing's going to get blocked. It's not going to just get blocked on the bottom first, and it's not going to happen all the time. You might occasionally see that during various like small events or short-lived events that do with the atmosphere, but you'll see a boat going on the horizon bottom first, or other objects disappearing bottom first on the globe on the horizon any time of day, any time of the year pretty much. And occasionally, again, you might get little glitches due to the weather and due to atmosphere conditions, but the majority of the time that's how objects disappear over horizon bottom first. and that's due to it being from going over a sphere, which I stated in my other video. So hopefully this answers pretty much any questions about with looming and sinking, or why objects appear higher and lower than they actually are due to atmospheric refraction. And if you have any questions or comments, leave them below in the comment section, and I hope this helped you out.